Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 22 from the IGCSE 0580 Cambridge specimen paper B for the 2025 new syllabus. And this question here is about similarity and also forming equations. So it's an algebraic and geometric topic. One of them, you're dealing with forming equations, but from a geometric type of problem involving similarity, as it says. So here it says, in this question, all lengths are given in centimeters. Triangle ABC is mathematically similar to triangle ADE. So ABC, which is the big triangle, and ADE, which is the small triangle. They didn't actually have to tell us that they're similar, because these parallel lines should make us realize that this angle is the same as this angle, and this angle is the same as this angle, and this is a common angle in both triangles. So we should be able to deduce by ourselves that these triangles are similar triangles. So we could do the following. I'm just going to draw this triangle outside of the shape just to make it clear. So I'm going to group this together first, and I'm going to move it out here. So basically, this is A and D and E, and it's similar to the big triangle ABC. Okay, and we know that the length from here to here is x plus 5 from A to E, and the length from D to E is 2x. And the length here is 10, which means the length on this whole length here which I will this whole length here is going to be x plus 5 plus 7.5. That's x plus 12.5. Okay, that's the length from there to there. All right, so there we have these two triangles. Okay, so we know that there are similar triangles, so the ratio of the corresponding sides will be the same. So if I do x plus 5 divided by x plus 12.5, this side divided by that side, it will give me the same ratio as 2x divided by 10. That will give me exactly the same ratio. Okay, so that should lead us to this equation, hopefully. So we can just multiply or cross multiply. In fact, if I write this the other way around, it'd probably be better to start with. So 2x over 10 is equal to x plus 5 over x plus 12.5. So if I now cross multiply, so I multiply both sides by 10 and multiply both sides by x plus 12.5, end up with 2x times x plus 12.5 is equal to 10 times x plus 5. So 2x times x is 2x squared. 2x times 12.5. Now 2 times 12 is 24 and 1 is 25. So that's 25x is equal to 10x plus 10 times 5 is 50. Don't forget to multiply the 10 with both the terms inside the bracket. So hopefully now this will work out to be the same as that. So we have 2x squared plus 25x minus 10x and minus 50 equals 0, which leaves us with 2x squared plus 15x minus 50 is equal to 0, which is exactly what we have to show. Okay, so it's best to show your steps very clearly and carefully when they say show that. So even this step of subtracting 10x from both sides and 50 from both sides, show that before you write the answer. When you have these type of show that questions, it's very important that you do so. Okay, not just write down the answer. Like you don't just, for example, write this down and then the answer. You have to show these intermediate steps to make sure you get the full marks. So that's A, part 1 is constructing an equation from a problem involving some geometry. And part 2 says solve by factorizing 2x squared plus 15x minus 0 equals plus 15x minus 50 equals 0. So we have to solve this by factorizing. So they've told us which method to use. So we're not going to complete the square, for example. We're not going to use the quadratic formula. we are going to factorize. And this is something now which many students would be able to escape in the old days when it came to factorizing. They would be able to use a calculator to find the final answers and then show their steps working backwards, making it look like they factorized. But now with this paper here, where it's non-calculator, there's no escaping for us, except that we should know how to factorize. And there's multiple ways we can do factorizing. The way that I like, I'll show you first. And it is basically the same as the second method I'll show you. I like to do it like this, like in a visual kind of way. So I will write down the x squared term in the top left and the constant term in the bottom right. So I have 2x squared and minus 50. And I'm going to multiply these two numbers together to give me a product of 100x squared. And it's negative 100x squared. Okay, so the sum of these two numbers, the product of these two numbers must be the same as this. The product of these two numbers must be the same as this, but their sum must be 15x, positive 15x. So you've got to think of two numbers that when you multiply them together, you get 100, and when you add them together, you get 15, and they have different signs. So one of them has to be positive, one of them has to be negative, so that we get a negative product. And I thought of the numbers straight away. It's basically 20 and 5. Okay, 20 and 5. 20 has to be positive sum, so 20x and minus 5x. Those are the two numbers. When you multiply them, you get 100. And when you add them, you get positive 15x. Okay, so that's quite simple to find. If you're not sure, you can go through the whole palaver. 100 times 1, 50 times 2. Now, that will give us 99 as a difference we're looking for. Different signs, so it will be a difference between the numbers. You can say 3 times nothing, no. 4 times 25, well, that gives us 21. We want 15. And then you'll soon come to 5 times 20, that's 100. And the difference between them is 15. So it doesn't take too long to get there if you are going to go through all the combinations. Okay, and now we can basically take out the common factor of these two, 2x squared and 20x. The common factor is 2 and x. And then I can just use multiplication to find the other part. So 2x times something here gives me 2x squared. Well, that's x. 2x times x is 2x squared. 2x times this number must give me 20x. Must be positive 10. 2x times 10 is 20x. And what goes out here must multiply with the x to give me this, because this is like the area of this little rectangle. X times something gives me minus 5x. That's minus 5. So I end up with x plus 10 times 2x minus 5 is equal to 0. All right, so that's one way of doing it. Okay, I'm going to continue to answer in a minute, but there's other ways of doing it. Some people like to split up the middle term into two parts, and the two parts are found in exactly the same way as I've done this. Exactly the same. They must multiply to give you the same as these two, which is minus 100x squared, and they add to give you 15x, so it's going to be plus 20x minus 5x. So you have 2x squared plus 20x minus 5x minus 50 equals 0. So we take out the common factor from these two. We factorize by what's called grouping. So we group these together, we group those together, and then we factorize them separately. So 2x is common in these two terms. And then you're left with x plus 10 inside the bracket. And there's a minus sign, so I'll write minus. Common factor here is 5. We're going to have x, and then you're going to have a plus as well, because minus 5 times minus 10 gives us minus, this must be plus. Minus 5 times plus 10 gives you negative 50. That must be positive here, equals 0. We notice now we have a common factor of x plus 10 in both of these terms. So we can write the common factor as x plus 10. And then x plus 10 times 2x gives us this term. And x plus 10 times minus 5 gives us that term. So we got the same answer, of course. So that means either x plus 10 is 0 or 2x minus 5 is 0, which we can say x equals negative 10 and 2x equals 5. So x equals 5 over 2. Okay, so x equals negative 10 or 5 over 2. In this part of the question, we're only asked to solve the question by factorizing, solve this equation. This question is out of context from the rest of the question. It's telling us to find the two solutions when you factorize this equation. Part 3 is now back into the context of the question. It says find the length of AC. Now if we go and look up here, and we notice here we have this length 2x. If x is negative 10, then this would be a negative length. And so would this part be negative length as well. So x cannot be equal to negative 10. Otherwise it wouldn't make sense. You cannot have negative lengths. So this is where we put it back into the context of the question and we say, okay, the length x must be 5/2 and x equals minus 10. We can't accept that value. So the length AC was given by the expression, as we learned earlier, x plus 12.5. AC was the total length from here to there, which is x plus 12.5. So AC is equal to x plus 12.5, x plus 12.5, which is 5/2, which is 2.5, plus 12.5, which is going to give you 15 centimeters. So that's the answer to this question. Okay, now for part B of this question from the this question number 22. Now part B of this question here is about the area of this triangle ABC, which is the big triangle is k centimeters squared. Find an expression for the area of the quadrilateral BCED. Give your answer in terms of k. So what we know is that these two triangles are similar triangles. The small triangle here, which is called triangle ADE. Okay, this triangle and this triangle are similar triangles, as we learned earlier. And we know that this has a length of 15 and 10, and this has a length of 2 times 2.5, which is 5 here. And here the length will be, it's going to be 2.5 plus 5, which is 7.5. So we can see here that the ratio of the lengths of the big to the small is like 1:2, right? Or 2:1, you could say. So the big triangle is twice as long, the lengths are twice as big. The scale factor for area is going to be, for length is going to be a factor of 2, which means the scale factor of area is going to be a factor of 2 squared. Okay, so what we can do is we want to find the area of the rectangle. Okay, so we can think of this as the area of the whole thing. Okay, so the area of the whole thing, let me just get rid of this for a second. The area of the whole thing, so it's the area of the big triangle, which is A, B, C, minus the area of the small triangle, which is A, D, E. If I take away the area of the small triangle from the big triangle, I'm left with the area that's shaded. Now the area of the triangle ABC, the big triangle, is K. Okay, so the area of this is K. All right, and the area of the small triangle is going to be, the area of this triangle is going to be K times, now this is, the scale factor is going to be 1/2 in terms of length. Okay, so in terms of area, it's going to be 1/2 squared. So it's going to be 1/4 of K. Okay, because the area of the big triangle is K, the area of the small triangle is going to be 1/4 K. Why? Because it's smaller, so you put smaller over bigger, and then you square the factor because we're talking about area and not length. Because as we know, this, for example, here we have a length of 5, and here we have a length of 10. So if you want to find the area of the smaller triangle, you have to do 5 divided by 10, which is 1/2 squared times the area of the big triangle. So we can say that the area of what we're looking for, okay, the area of BCED is going to be K minus 1/4 K, which is 3/4 K square centimeters. So that completes this question. The last part here is all to do with similarity and area. And the whole of this question will be in the playlist, which you'll find in the top of this screen. You'll find the playlist for this paper. You also have a playlist here, which will be for the topic of constructing equations. And I'll also put a playlist here for similarity. Okay. And also, you will have a playlist here for solving quadratic equations. Okay, so by factorizing. So you'll see some different playlists here which relate to the different topics that came up in this video. So thank you for watching. We'll see you soon.